In this tutorial, we're going to be talking about Hooke's law and Young's modulus, what they're used for, and exactly how to implement them. Whenever we apply a force to a certain object, there will either be a compression or a tension, either in a positive or negative direction, and this is just as simply called deformation, where the shape deforms into a different shape. When looking at an object from a materials perspective, there's two things that we look at. We must understand exactly how much each bar will deform under a certain load, and looking at the truss as a whole and seeing how much exactly it'll change in shape. And the second thing is determining exactly when the deformation critical limit is, which is exactly when the object will break under a certain force. If a certain force F is applied to either end of the bar, then the bar will go under a certain change in length, and this change in length is called elongation, and we call this elongation delta L in Hooke's law and Young's modulus. If an applied force is positive, then the bar is undergoing tension and the elongation is positive, but if the applied force is negative, then the bar is in compression and the elongation is negative. Earlier this week we talked about the evolution of theories and exactly how theories have changed based on the fact that we know more and more through certain technologies and experiments and observations. This is exactly just like Hooke's law and Young's modulus. Hooke's law essentially only works in materials that go back to a certain equilibrium, but they don't exactly take into account that at certain stress levels a material can only hold a certain amount of weight, which is why we use Young's modulus, which is what it is you take an exact cube of the material that you're using and you measure its elongation, and we get the formula that's on the left. You take the area of the cube times the spring constant of that cube and all over the length of that object, and then you multiply it by the change in the length that occurs. The first example of where you're going to be doing is what is the Young's modulus of a certain type of steel, and the question is a steel rod with a cross-sectional area of 0.0625 square inches and a length of 1 inch stretches 5.5 times 10 to the negative 4th inches when loaded with a weight of 1,000 pounds. What is the Young's modulus of this type of steel? We're sorry for the lack of good formula writing, but we kind of got kicked out of the room we were using. These examples are very simple and self-explanatory. We simply just take the values that were given to us of F and of A and of L and of delta L, and we simply plug them into this formula, which is Young's modulus. And with some quick calculations, we essentially get 29 million pounds per square inch.
The next example is about the elongation of a popsicle stick. Popsicle sticks are typically made of white birch, which has a Young's modulus of approximately 15 times 10 to the 9th newtons per meter square. The nominal dimensions of a popsicle stick are 111 millimeters long by 9.5 millimeters wide by 2.1 millimeters thick. What would be the elongation of a popsicle stick if the tension force of 20 newtons, approximately 4.5 pounds, were applied to it?
The tricky thing in the denominator, is that you are given the area of the cube and the Young's modulus in standard measurements, but we need metric. So you simply solve for it and then change it to metric at the very end. You get the 0.007 millimeters, which is the elongation of the popsicle stick.